Linear Programming Day 2. We're going to take what we know about linear programming and we're going to add a layer to it. So today we're going to make sure that you can write objective statements and write the constraints, which are the inequalities. So instead of those being given to you, you now have to write those. From yesterday, you've already solved linear programming questions by graphing and finding the corners and using the objective statement. So when I look for the objective statement, I'm looking for the words maximum or minimum. So typically I want to maximize profit. I probably want to minimize costs, but that's the type of thing I'm looking for. I want to identify my variables. Once I've written my objective statement, it's easier to identify what my x and my y are. You're required to write those out. The rest of the information I need to organize. If I have a situation where I need only positive answers, then I have to make sure that I include y is greater than or equal 0, and x is greater than or equal to 0. And from yesterday, we've already done the last three: graphing feasible regions, finding the vertices of the corners, and answering the objective statement by using a table. So stop the recording right now and read the question. When you read the question, you should be asking yourself where you're maximizing or minimizing something, and notice it told me to minimize costs. So cost deals with dollars, and I'm going to go back through here and find all of the information about dollars. I noticed that bookcase A is $200, so I'm going to use that, $200 times bookcase A, plus the $125 for bookcase B. And what I want to do is I want to minimize that. So I'm going to minimize the cost. Notice that once I use the numbers, I cross them out so I don't reuse them. I need to identify my variables for graphing. So I'm going to call X bookcase A, and I'm going to call Y bookcase B. I'm going to organize everything around X and Y now. So I notice that the store needs at least 320 square feet of space. Bookcase A provides 32 feet of space. So 32 feet for every shelf A. I notice B is 16 running feet, so 16 plus 16 for B. Whoops, I didn't want to call it A, I wanted to call it X. 16 for B, which is Y, and I need at least 320, so that's going to be greater than or equal to 320 feet. I've crossed that information out so I don't reuse it. Looking at the next piece, base restrictions, the bookstore has room for at most 9 or 8 bookcases of A, so X has to be less than or equal to 8. Crossed it out so I don't reuse it. Bookcase B, which is what I'm calling Y, can be at most 12. And I have to remember, if I'm talking about bookcases, I can only have a positive number of bookcases. So I'm only dealing with the first quadrant. So I'm going to go and I'm going to graph those. The first one, 32x plus 16y greater than or equal to 20. I can rewrite that in slope-intercept form, or I can graph using the intercepts. If I use the intercepts, the first one is going to be a 10 for x, and it is going to be so again I have the 10 for my x-intercept, I have a 20 for my y-intercept, and use a straight edge when you draw these. And it needs to be greater than or equal to, which means I'm talking about the stuff over here. Okay? So I've graphed that. Now I need x is less than or equal to 8. So I go to 8. I know that that is a vertical line. Less than or equal to means it's going this direction. Graph that. Y is less than or equal to 12, so I need to go where y is 12. And it looks like we're talking about everything in this little tiny triangle right there. So now I need to identify my vertices. So from my graph, my points of intersection, this one would be 8, 12. That one right there looks like it's 8, 4. And I have one last point of intersection up here, and that looks like it is 4, 12. So I'm going to use that to figure out my maximize or minimize my cost. So I'm going to take 200 times x plus 125 times y, and I'm going to try to minimize those costs. So I'm going to use the point 412. I'm going to use the point 8, 4, and the last point is 8, 12. So putting those into the equation, 200 times 4 plus 125 times 12 gives me $2,300. I'm going to check the next one. 200 times 8 plus 125 times 4 is $2,100. Okay, so remember I'm trying to minimize my costs. I want the smallest value. Let's try the last one. And 200 times 8 plus 125 times 12 gives me $3,100. Again, I'm trying to minimize my cost. So the minimum cost is $2,100 when 8 of A and 4 of B are made.